Hello everyone. In this video, we're going to continue talking about lesson 10, which is inference for two categorical variables, okay? And so we've gone through, in the first video, we talked about how to compare them just using percentages. In the second video, we talked about how to actually calculate the test statistic, which you'll have to do in the homework. Excuse me. And in this video, we're going to actually go through and do a hypothesis test for association. So, and please excuse me if you hear snorting and barking and such. That's my dog who's having a fit. Okay. So, again, we'll start out with the statistic. Last time we learned how to calculate that statistic, but we never learned what mathematical model describes this situation. So for the proportions that we learned about in lessons 7 and 8, okay, they followed their test statistic, specifically in lesson 8, followed a normal distribution. Great. In lesson 9, we found out that for hypothesis tests for a mean, it followed a t distribution, okay, or a t model. This statistic follows yet another distribution or another model. It's called the chi-square distribution. Okay, chi-square distribution. In Greek, a chi looks like that. Okay, sort of squiggly x, and so when you see a squiggly x with a squared on top, that's the chi-squared distribution. Okay. All right. So some quick notes about the chi-squared distribution. Okay. It is a continuous distribution, which we don't really need to worry about. Okay. Properties of the chi-squared distribution. It's unimodal, just like the normal and the t. The chi-squared distribution is always skewed to the right. Okay, so it's not symmetric like the normal and the t. Okay, and the numbers of it are always positive. Okay, so that means that your test statistic is always going to be positive. You can never have a negative test statistic. It's characterized, or what I call parameterized, by degrees of freedom, and I'm going to call that degrees of freedom nu. I know that for the t we also had degrees of freedom, and I just called them df. That was my bad. Usually they are given a symbol, and that symbol is nu. Okay, nu, the Greek letter nu. Okay, and so when I talk about a chi-square distribution, or specifically a situation having a chi-square distribution or following the chi-squared model, I'll have x tilde chi-squared with a subscript of nu. Okay? All right. And so here are some references, or just a quick picture of different chi-squared distributions with different degrees of freedom. Okay? And so you'll see that as the degrees of freedom increase, the chi-squared distribution starts to look more and more like the normal distribution. Okay? Just like as the degrees of freedom increased for the t distribution, it started looking like the normal distribution. This is a recurring theme that you'll see a lot in statistics, but it's really beside the point for us. Okay? There's the chi-squared distribution. Now on to the actual hypothesis test. All right? So this is the moment you have all been waiting for, the steps that will help you complete the actual problems. Okay? So the hypotheses, and we have the null and alternative as usual. The null hypothesis is that the two variables are independent, and the alternative hypothesis is that the two variables are associated or dependent. Okay? You don't need to write both like I did here. Just write associated. Okay? So that's the hypotheses. The significance level, of course, is stated in the problem and problem specific, so we'll skip over that for now, but it serves the same purpose. as it always has. The assumptions of this test are a little bit different than the ones that we've seen before. Okay, the assumptions are one, that both variables are categorical. Okay, and so that's a pretty self-explanatory assumption, and one that's always going to be met for our problems. I won't give you two variables that aren't categorical. They will always be, so one is always met. Great. The second is that the data are taken randomly, which is one that which is an assumption that we've had all along, and it'll continue to be there. Okay, data is taken randomly, and then the one that we really need to be careful about is number 3, that all expected cell counts are at least 5. And I say that. Why do they have to be at least 5? There are some theoretical reasons that back up that sort of thing. But that's, again, sort of like a sample size condition that have become used to for different types of problems. The one that you really need to check when you check your assumptions, before you move on, are that all expected cell counts are at least 5. And I'll show you how to do that later. When I mean expected cell counts, I mean that expected table that we worked with in the last video. Step 4, or the next step, is calculating the test statistic, which you've done. Great. In practice, usually I'm not going to make you calculate the test statistic every time, right? Because that's just overkill. I want you to be able to do it and know how to do it, and then we're going to let statistical software do it for us. Okay? Great. The next step after the test statistic is the p-value. Usually when I wrote about these hypothesis tests before, I said there are 3 different situations where the p-value will look different in each situation. Not so here. It's always a right-tailed test, meaning that before we would have before this would mean it's always a greater than sign, but a greater than sign doesn't really make sense here. We're always looking for large values of the test statistic, not small ones. All right. So the p-value is always the probability of t greater than t, where t is the chi-square distribution and little t is the actual test statistic that we got. That really doesn't matter to you. I know it does to me, though, and so I have to say it. Where that test statistic has a chi-square distribution, approximately, and the degrees of freedom that we're using, so again, this is important here, because this is something we actually need to pay attention to. The degrees of freedom are r minus 1 times c minus 1. So what does that mean? R is the number of rows, and C is the number of columns in the table. So the degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So if in most of my examples that I've done previously, we've only had 2 rows and 2 columns. So the degrees of freedom would be 2 minus 1 times 2 minus 1, which is 1 times 1, or 1. Then we have 1 degree of freedom there. Here is a nice visual. If you look at the chi-square distribution and we look where the p-value is, or where we're looking for the p-value, it's always in the right tail. The decision and conclusion are going to be about the same before. Either you do or don't have enough evidence to reject the null hypothesis, and then you restate that in terms of the problem for the conclusion. So here's a nice summary, just a nice slide for you to look through. There are 5 steps here. I require a few more steps. But almost everything is here to give you a nice summary of what you need to do. All right, so let's do an example. I have a similar table. Okay, I've now just collected more data than my example before. So before I had 8, 3, 8, and 1. Now I have 40, 15, 40, and 5. And I ask, are gender and handedness associated? Okay, so that's what I'm interested in. The null hypothesis are that they are independent or not associated, and the alternative hypothesis is that they are associated or dependent in some way. It'll state in the problem what your significance level is here. I'm just going to assume it's 0.05 and go forward because I don't really have any setup to the problem. So that's my significance level. My assumptions are both variables, categorical. They have 2 categories each, so yes, they're categorical. Great. Are they randomly taken? You have to take it from me that this data was randomly taken, so great. Are all expected cell counts at least 5? Okay, of course, that's for theoretical reasons. You don't have to write the theoretical reasons part, but really write this down. And the answer to this assumption right now is we don't know because we haven't calculated that expected table yet. So we've got to wait and see. So let's move on. I'm going to show you output from statistical software. Okay, this output is going to be from Minitab. I'll show you how to do this in StatCrunch. It's going to look very similar. Okay, and so I'll show you the Minitab, but I'll also show you the StatCrunch later. It shouldn't be too confusing. So here is what the Minitab output looks like. Why am I showing you this? Well, first, it gives you the actual test statistic value and the p-value, so it's helpful. Also, it tells me the expected cell counts for this example. Okay? And so if you look over here at the actual table, you'll see 40, 15, 40, and 5. That's my actual table. Okay? And then below that, here's the legend of the table, okay, are the expected counts. So are all of them greater than 5? Can we move forward? But we have 44, 11, 36, and 9. All of them are greater than 5. So we can move forward and all our assumptions are met. So the next step is the test statistic. Okay? The test statistic, you won't have an option here. It gives an option of Pearson or likelihood ratio. If you ever would see this, okay, we're choosing the Pearson option. Okay, Pearson option. This is named after a person, not like the book that we're using. All right, so this is a person. His name was Carl Pearson. He came up with this method. Okay, and so this 4.04 is the value, is the chi-square value here. It tells me how many degrees of freedom there are as well. Right? So there's the test statistic. There's the p-value, also states it. Great. So the decision, this is my p-value. My significance level was 0.05. So the p-value here is less than the significance level. So we reject the null hypothesis. All right. And what does that mean? At the 5% significance level, there is enough evidence to conclude that there is an association between gender and handedness. Okay, so hopefully that made sense. Just a simple decision, simple conclusion, and we're done. All right, so there's a reading assignment, page 522 to 528 will take you through the calculation of the test statistic of the whole hypothesis test. Okay, and give you some more in-depth information than what I was able to give you here. All right, and I have one last your turn here. Okay, I have a hypothesis test where the rows represent how many years of education that the person was in, and so they made that 3 categories: low, medium, or high, and their view on abortion. Okay, their view on abortion, either positive, mixed, or negative. Right? So I want you to go through and ascertain if there's an association between the level of education and their view on abortion. For this example, assume a level of significance of 0.05. I'll see you in the next lesson.